So homework 27 starts off with looking at your function and where it might be increasing, decreasing, or constant given the graph. So on this one, it says determine the interval or intervals on which the function is strictly increasing. On the right marker. So if I look at my graph is decreasing here, constant here, it's increasing from here to here, constant, and then increasing. When you're looking at the section, you're looking at the domain. So this section that's increasing is from the 0 to the 1. This section is from 3 to 5. Now, different textbooks do the end marks differently. Some people say technically the end point isn't increasing or decreasing, so they use parentheses all the time. That's what I do. Other books will let you use a bracket in there and still count it as long as it's a filled-in dot, which all of these are going to be. So depending on who your instructor may be, you may see them with the brackets. I always just use a parenthesis. So it's just whoever philosophy is. Some people say, well, the endpoint can't increase or decrease, so they just use a parenthesis. So that's what we do. So it would look something sort of like that. Alex will take it either way. If you put the bracket there, it'll still count it right. So number 2 wants you to determine the interval where the function is decreasing. We have here a section that's decreasing, also over here a section that is decreasing. So the first section, the interval would go from -7 to -5, and they always go from left to right, smallest to largest, by the way. And then my second interval is going from -3 to 0. The third one wants you to determine the intervals where it is constant. And in this case, we only have one interval that is constant. That interval would be going from 2 to 6. Number 4, 5, and 6, we are graphing an absolute value function. A normal graph of an absolute value function looks like a V, and the vertex is at 0, 0. That's if you don't have any horizontal or vertical shifts. If you have adding and subtracting, you're going to have horizontal and vertical shifts. The end number shifts the graph up or down, in this case down 3. The number in with the x kind of does the opposite, because you have to set it equal to 0. So if x plus 4 equals 0, x equals -4. So that actually is going to shift it to the left 4 places. So in my table of values, my vertex is going to be at -4, -3. Now in Alex, they're only going to make you do 1 point on each side of that. So we're going to put -3 and -5 in for our other 2 points. And then basically we're just going to substitute it in and solve. So -3 plus 4 is going to give you 1. The absolute value of 1 is still 1. 1 times 2 is 2. 2 minus 3, -1. Now when I do the -5, I should get the same answer in order for it to look like a V. -5 plus 4 is -1, but the absolute value of -1 becomes +1. 1 times 2 is 2, and 2 minus 3, -1. So -4, -3 is where my vertex is. And I have a point at -3, -1, and -5, -1. When you draw this on Alex, you're going to have to use the ruler and draw 2 separate lines. You want to draw from the vertex through the end point. Doesn't like it if you stop right on the end point, and it doesn't like it if you go past your vertex. Then you'll set the ruler on the vertex and the other end point, and again, just make sure you draw all the way through that end point. Don't stop on it. It doesn't like that for some reason. So my graph looks something sort of like that. So an absolute value function always looks like a V when you graph it. Or if you're looking at a graph and it looks like a V. you know, it was an absolute value. I lost my problems. 5, that'd be where we're at. So if I look at the next one, we have negative 2 times the absolute value of x minus 1 minus 3. My vertex, the x value would be at 1 and negative 3 would be my vertex. So 1 minus 1 would make that 0, and then if that's 0, the y value ends up being negative 3. But we'll talk about horizontal and vertical shifts. Shifts to the right 1 and down 3. So I have to go 0 and 2 to get 2 points right on each side of that 1. If I put 0 in there, 0 minus 1 is negative 1. The absolute value of negative 1 becomes positive 1. 1 times negative 2 is negative 2. Negative 2 minus 3, negative 5. And if I put my 2 in there, 2 minus 1 is 1. The absolute value of 1 stays 1. 1 times negative 2 is negative 2, and negative 2 minus 3, negative 5. So 1 and negative 3 is my vertex, and then 0, negative 5, and 2, negative 5 would be my other 2 points. And I'm going to draw from my vertex through each of my endpoints. And later we'll talk about reflecting, but since there's a negative coefficient in front of my x's, that flipped it across the x-axis, and that's why my v is upside down. Just stay where it's supposed to. So number 6, if you look at that, your vertex is going to be at negative 3, positive 4. So negative 2 and negative 4. So if you put negative 2 in there, you would get a y value of 7, yep. And if you put negative 4 in there, you're also going to get a y value of 7. So negative 3 up 4, negative 2 is up to 7, and negative 4 is also up to 7. And then we can draw our absolute value function. So 7, 8, and 9, now we're going to graph a parabola instead of an absolute value function. Same thing holds true. I'm going to have my horizontal shift and my vertical shift. It's just going to look like a U instead of like a V when I'm done. On the parabolas, they make you do the vertex and 2 points on each side. So first thing again I want to do is figure out what my vertex is. So my vertex is going to be at negative 4 and 1. So I want 2 points on each side of that, so negative 3 and negative 2, negative 5 and negative 6. And then I'm just going to plug them in and solve. So negative 2 plus 4 is 2, 2 squared is 4, 4 plus 1 is 5. Now when I do the negative 6, I should get the same answer, so I'm going to hop down and do the negative 6. Negative 6 plus 4 is negative 2. A negative 2 squared is a positive 4, and 4 plus 1, 5. On my negative 3 plus 4 is 1. 1 squared stays 1, and 1 plus the 1 on the end would give me 2. Should get the same answer for the negative 5. Negative 5 plus 4 is negative 1. Negative 1 squared is a positive 1, and 1 plus 1 is 2. So plotting my points there, negative 2, 5, negative 3 is up 2, negative 4 is up 1, negative 5 is up 2, and negative 6 is up 5. These you just put your 5 dots on and hit the graph button, and then it's going to put your parabola on your graph for you. then, if you pick out your vertex on number 8, it would be at 2 and 4. So 2, 1, 0, and 3 and 4, something like that. Doesn't matter what order, just so you get them all in there. So if I put 0 in for x, what would I get for y? 8. And then I'm going to jump down to the 4. If I put 4 in for x, what am I going to get for y? I'm also going to get 8. And if I put the 1 in for x, I get 5. And the 3, also get 5. So 0 over up 8, 1 over up 5, 2 over up 4, 3 over up 5, and 4 over up 8. Hit the graph button, and you will have your parabola. Number 9, we're graphing our parabola. First thing we're going to do is pick out our vertex. Our vertex would be at -3, -2. So, -3, -2, -1, -4, -5, or something like that. So if we put -1 in for x, we would get 2. And when we put -5 in, we probably should get the same 2. If we put -2 in for x, we would get -1, which means we also should get -1 for a -4. So, -1, 2, -2, -1, or positive -2, paragraph that way. -2, -1. There we go. -3, -2, -4, -1, and -5, positive 2. I slowed down, I get it right. Looks something sort of like that. So, let's get your vertex, the opposite of that number, same as that number, and then 2 points on each side of that, and it makes it pretty easy to graph. 10, 11, and 12, they're having you graph a square root function. And on your square root function, because the square root of a negative is undefined, what they're going to have you do is start by finding what you should use in your table for your x values by setting whatever's under the square root equal to the first 4 perfect squares. In this case, we just have an x under the square root. So we're going to say, okay, x has to equal 0, which is my first perfect square, 1, 4, which is 2 squared, and 9. Didn't have to do much to solve those because I only had just the plain x under there. So when I make my table, I'm going to use 0, 1, 4, and 9 so that my values all come out nice because I can do the square root of all of those numbers. So square root of 0 is 0, 0 plus 5 gives me 5. Square root of 1 is 1, 1 plus 5 is 6. Square root of 4 is 2, 2 plus 5 is 7. Square root of 9 is 3, 3 plus 5 is 8. And so I'm going to plot those points. 0 over up 5, 1 over up 6, 4 over up 7, and 9 over up 8. And go straight here. And so what my graph is going to look like is this is going to be my end point. It's going to go through these points and it's going to shoot off somewhere in that direction. You'll just have to hit the graph button and it'll connect your dots for you. But you have to do the end point and then 3 additional points. So when you have the next one, if I can find it here, they're going to have you do this. The x minus 1 is all under the square root. So we want x minus 1 to equal 0, x minus 1 to equal 1, x minus 1 to equal 4, and x minus 1 to equal 9 because we want perfect squares ending up under our square roots. So if we solve each of those, we're just going to add 1. So we want x to equal 1. 1 plus 1 is 2, 4 plus 1 is 5, and 9 plus 1 is 10. And those are the values we're going to put in for x on our table. And then they should come out to nice perfect squares. So plugging them in, 1 minus 1 is 0, square root of 0, still 0. 2 minus 1 is 1, square root of 1, 1. 5 minus 1 is 4, square root of 4. And 10 minus 1 is 9, square root of 9, 3. So every value came out to a nice whole number answer that you could easily plug. So 1 over up 0, 2 over up 1, 5 over up 2, and 10 over is up 3. And my graph looks something sort of like that. So number 12, same kind of thing. I've got the x plus 2 underneath the square root. So we want x plus 2 to equal 0, to equal 1, to equal 4, and to equal 9, so that we can do the square roots. So on each of those, we're going to minus our 2. And so in our table, what value should we use for x? If you solve each of those, you're going to get -2, then -1, then 2, and 7. So those are the 4 values we want to plug in for x. Should work out to nice perfect squares. So if we put -2 in for x, y is going to be 0, since we get the square root of 0. If we put the -1 in for x, we're going to get 1, because we get the square root of 1. If we put a +2 in for x, we would get the square root of 4, which is 2. And if we put the 7 in for x, 7 plus 2 would be 9, so the square root of 9 is going to be 3, right? So we get nice perfect squares underneath there by setting them equal to the perfect squares and then doing our adding or subtracting, and then we can plot our points. So -2 is up 0, -1 is up 1, 2 is up 2, and 7 is up 3. And our square root function looks something sort of like that. And the problem type 2, same kind of thing. I want to figure out what value should go in my table for my x's. And then I'm just going to plug them in and solve. In this case, we just have the plain x underneath there like the first one on the other ones. So x is just going to equal 0, 1, 4, and 9 because we want them all to come out to nice perfect squares. And then we're going to plug them in and solve. So square root of 0 is 0. 2 times 0 is still 0. 0 minus 1 gives us a -1 answer. Square root of 1 is 1. 1 times 2 is 2. 2 minus 1 is 1. Square root of 4 is 2. 2 times 2 is 4. 4 minus 1, 3. Square root of 9 is 3. 3 times 2 is 6. 6 minus 1, 5. So now we've got our 4 points and we can plot those. 0 over down 1, 1 over up 1, 4 over up 3, and 9 over up 5. And our absolute, our square root function looks something sort of like that. So on number 14, we're doing 3 times the square root of x minus 1. Here, x minus 1 is underneath the square root. So we want to take the x minus 1 and set it equal to 0, 1, 4, and 9, and solve each of those. So we're going to add 1 to each of our values to solve them. So in our table, what 4 values should we use for x?
One,
2, 5, and 10, and then we should get nice values that work out for our square roots. So if we put 1 in there, 1 minus 1 is 0. 0 times 3, still 0. 2 minus 1 is 1. Square root of 1 is 1. 1 times 3, 3. 5 minus 1 is 4. The square root of 4 is 2. 2 times 3 is a 6. And 10 minus 1 is 9. Square root of 9 is 3. 3 times 3 is 9. So over 1 up 0, over 2 up 3, over 5 up 6, and over 10 up 9. And our square root function looks something sort of like that. And 15 must be the last one here. Again, we're doing a square root function. We want to take the part that's under the square root, x plus 2, set it equal to 0, to 1, to 4, and to 9, so that we end up with values that work out nicely. So we're going to subtract 2 on all of these. And so in our table, we would use what 4 values for x? Negative 1, 2, and 7. So if we put negative 2 in for x, our y value is going to be 6. 0 plus 6 is 6. If we put our negative 1 in for x,
7.
we get 7. If we put our 2 in for x,
8.
we get 8. And if we put our 7 in for x,
9.
3 plus 6 gives us 9. So we get all nice, easy numbers to work with that we can plot. Negative 2 up 6. Negative 1 is up 7. Positive 2 is up 8. And positive 7 is up 9. And our square root function looks something sort of like that. All right, that should be the next 5 things on your pie chart.